If you buy the most, sophisticated enterprise software on earth, but your internal culture just totally rejects it, well, you've basically just bought a multi-million-dollar paperweight.
A very, very expensive paperweight.
Right. Welcome to the Deep Dive. Today, we're taking a really close look at the APICS Certified Supply Chain Professional Learning System. Specifically, we are exploring how these massive global networks are being digitized.
And what's fascinating here is the central tension in these materials, because we're watching these massive supply chains abandon archaic paper-based webs for, well, highly advanced autonomous networks.
Yeah.
But the technology itself is rarely the actual point of failure. I mean, the code usually functions perfectly.
The failure almost entirely comes down to the human frameworks, right? Like how the people are managed during the rollout.
Exactly. The human element is what breaks.
So if you're listening to this and prepping for a boardroom meeting or studying project management, or you're just insanely curious about how the world gets built and shipped, our mission today is to shortcut your way to being incredibly well-informed on all of this.
Without the total information overload.
Right. So before we can figure out how to manage the humans, we really need to understand the tools they're being asked to use.
Okay, let's unpack this. Upgrading a supply chain today is basically like upgrading a dumb house to a smart house, but on a planetary scale.
That's a great way to put it. And the foundational layer making all of that possible is cloud computing. Moving from on-premise servers to SaaS and IaaS models, it just gives organizations the flexibility to scale their computing power up or down based on, say, seasonal demand.
Without having to maintain these massive physical server farms.
Right. But, the APICS text does throw some necessary cold water on the cloud hype.
Oh, absolutely.
Beyond the obvious risks like ongoing lease costs or the fact that you have an absolute dependency on your internet connection, the real bottleneck they identify is latency. Which, that sounds like a minor IT complaint, right? It's a little lag.
Right.
But in a physical warehouse, latency is literal physical downtime.
It's everything.
Think about a massive distribution center running automated conveyor belts and robotic sorting arms. Those warehouse management systems, they demand millisecond response times.
Milliseconds.
So if an optical scanner reads a barcode and has to send that data to a cloud server, 3 states away, just to ask which lane a package should go down, that slight delay in the return signal means the package has already moved past the diverter arm.
And it misses its chute. Yeah, the cloud simply struggles with that hyperlocal, instantaneous physical response that forces companies to rely on edge computing.
Meaning they keep the processing power physically on site.
Exactly. You keep servers on site just to manage the fast twitch robotics, while the cloud handles the broader network data.
So how do these systems actually process the sheer volume of data being generated without just choking? Because the sources draw a very sharp line here between expert systems and true machine learning.
Yeah, they do. So expert systems are fundamentally rigid. They operate on heuristics, which are essentially highly complex, nested if-then rules that are established by human programmers.
Right. So if X happens, do Y.
Exactly. They are incredibly useful for diagnosing known problems, but they cannot evolve past their programming. Machine learning, on the other hand, feeds on massive data sets to find invisible patterns. It literally trains itself to improve its own predictive accuracy over time.
And the application of that for predictive analytics just completely changes the physical reality of a factory floor.
Oh, it's night and day.
Instead of running a piece of manufacturing equipment until it snaps or, doing scheduled maintenance, whether a machine actually needs it or not, the AI is continuously ingesting vibration frequencies, temperature fluctuations.
Acoustic profiles.
Yeah, acoustic profiles from the hardware. It flags anomalous patterns and tells you, hey, the motor's going to fail in exactly 3 days.
And that capability alters the entire corporate inventory strategy. A company no longer needs millions of dollars in spare parts just sitting idle in a warehouse just in case something breaks. They order the replacement bearing exactly when the algorithm predicts the impending failure.
Wow. And it changes the physical reality for the workers on the floor, too. Because warehouse picking used to involve walking down aisles with a clipboard or maybe a handheld RF scanner.
Right.
But the integration of augmented reality and voice-activated wearables is stripping all of that away.
Yeah, think about it. A worker looks down an aisle and their AR smart glasses overlay a holographic path directly onto their field of vision, highlighting the exact bin they need to pull from.
That's wild.
And their hands remain completely free. The reduction in physical fatigue and the drop in picking errors is just staggering when the worker doesn't have to constantly look away from their task to check a screen.
But wait, with all this automation, specifically RPA, like robotic process automation handling repetitive tasks, where does the human actually fit in? Doesn't the source text warn that customers get highly frustrated with bots?
Oh, they do. Customers will actively demand human intervention.
Right. So where's the human in this automated loop?
Well, RPA is designed to clear the noise, not handle the nuance. It uses software bots to emulate human execution of predefined, highly repetitive tasks. So if a client simply wants to know where their freight is located or needs to process a standard customs form, RPA handles it instantaneously.
It acts as a filter, basically.
Exactly.
Because when a shipment of critical medical supplies gets detained at a port, or you have a VIP client who is furious over a delay, you need human empathy. You need complex, unstructured problem solving.
Right. RPA clears the repetitive backlog, so the human workforce actually has the bandwidth to manage those unique exceptions.
Okay, here's where it gets really interesting, though, because having a bunch of smart gadgets is totally useless if they don't talk to each other. We have to move from isolated tech to an intelligent supply chain.
They have to communicate securely.
Right, and to get there, the APICS material leans heavily into blockchain integration. And I kind of have to push back on this.
Oh.
Yeah, I mean, we're talking about physical supply chains, moving steel, pharmaceuticals, consumer goods. Isn't blockchain just crypto hype? Like, a centralized database works perfectly fine for massive ecosystems like Amazon. Why on earth does a supply chain need blockchain?
That's a super common reaction. But a centralized database is only highly efficient if you are a single corporate behemoth controlling your entire internal ecosystem.
Like Amazon.
Like Amazon. But most global supply chains involve dozens of fiercely independent actors. You've got raw material suppliers, freight forwarders, international customs agents, port authorities, rail lines.
And none of them trust each other.
Exactly. No single entity trusts the others enough to hand over control of a centralized database. Blockchain solves that foundational trust deficit.
Because it operates as an irrefutable shared ledger.
Yes. Every time a physical container changes hands, a block of data is created, it's time-stamped, and it's cryptographically linked to the previous block. So if a shipping container of perishables gets held up at customs and the refrigeration fails, nobody can retroactively alter the logs to cover up who had possession of it.
Wow, okay, that actually makes a ton of sense.
And the APICS text points to massive industry adoption to prove this isn't just hype. Look at TradeLens, which is the joint venture between IBM and Maersk, or the Global Shipping Business Network.
Oh, right, for water shipping.
Yeah. When you establish a secure, unalterable chain of custody across competing organizations, you prevent counterfeit parts from entering the supply chain, and you can instantly resolve multi-million-dollar disputes over liability.
The shipbuilder case study in the text is a perfect blueprint for how all of this tech weaves together. Because building a massive naval vessel requires managing millions of individual moving parts.
It's mind-boggling.
And the shipyard uses IoT sensors and intelligent asset management to create what they call digital twins of their physical equipment.
Right. And a digital twin is essentially a virtual replica of a real-world asset that engineers can run live simulations on. So instead of a team physically inspecting a shipyard crane to figure out why its load capacity is degrading, they just pull up the digital twin.
Because the twin is being fed real-time stress data from the actual crane's IoT sensors.
Exactly. The engineers can simulate different wind speeds and lifting angles on the digital model to identify the structural flaw without ever stepping outside.
And then, to track the massive inventory of equipment, they use a mix of active RFID tags on the heavy machinery so it constantly broadcasts its location, and passive QR codes on the smaller hand tools that just get scanned at checkout.
And blockchain runs quietly beneath all of this data collection. It ingests the RFID pings and the QR scans to build a completely verified timeline of asset usage.
So the engineers can optimize exactly how many tools they need.
Right. An advanced analytics engine looks at this perfect, unhackable data and recognizes that, hey, while the shipyard owns 50 expensive welding machines, the data proves they have never utilized more than 38 simultaneously.
Oh, wow. So they can liquidate the excess capital equipment with total confidence.
Exactly.
I mean, if you're listening, imagine applying that level of visibility to your own workplace, knowing the exact location, condition, and custody history of every single resource.
It's incredible.
The capability is amazing, but the financial risk of building it is terrifying. I mean, the corporate graveyard is full of companies that bankrupted themselves trying to implement enterprise technology at this scale.
Oh yeah, mitigating that risk requires ruthless discipline long before a single software license is ever purchased.
It's like buying a suit, right? Do you buy it off the rack and tailor it slightly, or do you commission a bespoke suit from scratch?
That's exactly the choice. And if we connect this to the bigger picture, the APICS methodology demands a comprehensive gap analysis first. You have to methodically map the exact difference between your organization's current capabilities and your future ideal state.
Before you buy anything.
Yes, because the most common trap organizations fall into here is the desire for excessive customization.
Enter the 80-20 rule.
Yes, the 80-20 rule. The text strongly advises finding packaged, off-the-shelf software that meets roughly 80% of your needs out of the box.
And then you just adapt your internal business processes to cover the remaining 20%. Because modifying raw source code to perfectly fit your current quirks is a massive hazard.
It really is.
Think of it like buying a modern smartphone.
Yeah.
Buy the standard hardware, you use its native operating system. If a feature isn't exactly how you want it, you just change your habits. If you try to jailbreak the operating system to force it to do something custom, the phone might work today.
Might work today.
But the second the manufacturer pushes a mandatory security update next year, your custom code violently clashes with the update, and the entire device bricks itself.
And that causality is identical in enterprise software. Every time the software vendor releases a critical patch, a team of really expensive internal developers has to meticulously rewrite and retest your customized code to ensure the patch doesn't break the whole system.
The total cost of ownership just skyrockets.
It goes through the roof. It is infinitely safer and cheaper to change how your organization functions to fit standard software than to alter the software to fit your organization.
And management also has to resist the urge to deploy a solve-everything-at-once mega project. You have to take incremental steps.
Yeah.
Use strict go-no-go milestones to ensure the tech actually delivers value before scaling it.
Right. And once the standard software is procured, the focus shifts to the actual installation.
Which requires project management.
Yes, which the text makes a hard distinction between. Daily operations are continuous and ongoing, but project management operates with a definitive start and end date.
So what does this all mean for the people on the ground? Like, are we building a bridge or are we developing an app?
Well, that dictates your framework. Depending on what you're implementing, you use two entirely different management philosophies, traditional or agile.
Okay, so traditional or waterfall project management, that's best for physical installations. Like, if you were installing 2 miles of automated conveyor belts in a new facility, you cannot decide halfway through the build to just move the loading docks.
Right, you can't just pivot.
You build a work breakdown structure, or WBS, to map out every single discrete task. If it's not on the WBS, it's out of scope and it doesn't happen.
And the WBS allows the project manager to identify the critical path. This is the longest sequence of strictly dependent activities.
Right, so you cannot pour the concrete floor until the subterranean plumbing is laid. And you can't bolt down the heavy conveyor belt until the concrete fully cures.
Exactly. The critical path dictates the absolute shortest possible time the project can be completed in. A single day's delay on the critical path delays the entire facility launch by a day.
But let's say executive leadership demands the facility opens a month early to hit some quarterly target. The project manager basically has 2 techniques to speed things up: crashing or fast tracking.
Right. So crashing the schedule involves throwing additional resources at the critical path tasks. You authorize heavy overtime, or you hire double the contractors to pour the concrete faster.
Which drastically increases your financial costs, but it doesn't necessarily increase the structural risk of the project.
Exactly. But if the budget is locked and you cannot afford to crash it, you are forced to fast track.
And fast tracking means taking tasks that were carefully planned to be sequential and running them concurrently.
Yes. You start assembling sections of the conveyor belt in a temporary staging area before the concrete in the main facility is even poured. It doesn't cost extra money up front, but the risk of catastrophic rework skyrockets if the measurements end up being off by even a few inches.
Yikes. And to protect the project from leadership constantly shifting requirements, traditional management relies on the strict gatekeeping of a change control board.
They are the defenders against scope creep.
Scope creep, where the client keeps adding just one more little feature.
Right. Or gold plating, where the engineering team decides to add extra unrequested features just to show off their skills. Both of those just destroy budgets and timelines.
But that rigid, highly defensive posture is entirely wrong for software development. For highly variable digital projects, the text pivots to agile project management, specifically frameworks like Scrum.
Yes. Agile assumes requirements will change constantly as users actually interact with the new tools.
So instead of a massive, immutable schedule, Agile breaks the work into short, fixed iterations called sprints.
And teams use a Kanban board visualizing work flowing from a backlog to in-process to done just to manage their current sprint.
And the goal is to develop a minimum viable product, right? An MVP.
Yeah.
You get basic functional software into the hands of real users as quickly as possible to gather immediate feedback. If the warehouse workers find the new AR interface confusing, the development team just adapts the design in the very next sprint.
You cannot do that with poured concrete.
Nope. But, the APICS text leaves us with a pretty stark reality here. Projects eventually end. The software is deployed, the conveyor belt is powered on, the Scrum board is archived, and business operations just take over.
Yeah.
And if the underlying culture of the company hasn't fundamentally changed, the workforce will abandon the new tools and quietly revert to their old spreadsheets the second the project manager stops watching them.
That happens all the time.
It's like going on a crash diet, right? Losing 20 pounds in a month. That's the project. You have a start date, you have strict milestones, you have an end.
Yeah.
But keeping the weight off for 5 years requires a total lifestyle change. You have to permanently alter your relationship with food and exercise. That is change management.
And change management is constantly dismissed as a soft skill, but it is a structural necessity. Digital transformation completely fails without it.
So how do you architect that kind of lasting lifestyle change within a corporation?
Well, the sources rely on John P. Cotter's 8 accelerators for change management. And the real engine of this framework is identifying the big opportunity.
The big opportunity.
Right. This cannot simply be a reaction to a broken process or minor inefficiency. It must be a proactive, exciting vision of the future that aligns with the organization's core values, but pushes them into a completely new era.
Because people won't endure the friction and pain of changing their daily habits just to save the company 3% on logistics costs.
No, they won't.
But they will endure the pain for a big opportunity that redefines their whole industry. Yeah. And to execute on that vision, Cotter introduces a really fascinating structural tension between a network and a hierarchy.
This raises an important question about how organizations operate. You must maintain the traditional hierarchical structure to handle daily administration, payroll, routine operations, just to keep the lights on.
Right.
However, you cannot innovate effectively within a rigid hierarchy that requires 5 levels of approval for every new idea. So alongside the hierarchy, you establish a network structure.
Like a fluid, decentralized task force that mimics an entrepreneurial startup.
Exactly. The network drives the big opportunity forward, experimenting and taking risks, while the hierarchy keeps the lights on. They share the same employees, but those individuals operate with entirely different mindsets depending on which system they're interacting with at that moment.
Wow. But for an individual employee to actually embrace this transition on the factory floor, the text outlines 3 absolute prerequisites: desire, knowledge, and skill.
And if any single one of these is missing, the digital transformation collapses at the individual level.
So desire means the employee understands exactly why this change benefits them personally, not just the shareholders. They have to actually want the new reality.
Yeah, and knowledge means they know what the end state looks like. They actually understand the new process they're moving toward.
And skill means management has provided the rigorous training and the protected time required to actually operate the new tools.
Look at what happens when these are out of balance. If a worker has the skill to use the new software, and they know the goal, so they have knowledge, but they don't see why it matters to them.
They lack desire.
Right. They will passively resist the rollout and just spread cynicism.
Or, if they have the desire and the skill, but no knowledge of what the actual workflow is supposed to be, they just run around enthusiastically breaking things.
Exactly. Good change management meticulously ensures all 3 elements are locked in before the switch is ever flipped on the new technology.
Because the technology is merely the enabler.
The competitive advantage comes entirely from the discipline of the humans managing it.
So to synthesize all of this, to truly be well informed about the future of global operations, you have to look past the dazzling hardware. The real magic isn't in the cloud architecture, the AR headsets, or the cryptographic ledgers.
No, it's not.
It comes from having the restraint to conduct a rigorous gap analysis and honor the 80-20 rule to avoid crippling technical debt. It's about deploying agile or traditional PM frameworks tailored exactly to the physical or digital reality of what you are building.
and ultimately guiding the human workforce through the hurdles of change management.
Exactly. So whether you, the listener, are spearheading a multi-million-dollar logistics overhaul, or you're just trying to get your small team to adopt a new scheduling app, leaning into tools like the 80-20 rule and Kotter's big opportunity, those are your universal shortcuts to an enduring deployment. We've seen how predictive analytics can process massive data sets to optimize shipping routes and forecast mechanical failures. But as these intelligent supply chains become more autonomous, as they begin tweaking and optimizing their own parameters in real time, who initiates the next massive leap forward?
That's the real question.
Will the next big opportunity, the kind of visionary shift that transforms a company's entire culture, be sparked by human intuition? Or will it be hallucinated, planned, and prescribed entirely by a machine learning algorithm analyzing data we can't even comprehend? Something to think about. Thank you for taking this deep dive with us. Keep questioning, keep exploring, and we'll see you next time.